Welcome back to your city. We've taken the show outside right now, away from the labs, and that's because one of the key parts of this conference that's taking part in our city deals with forestry. And that's where you, Steve Price, come in. You're with the Alberta Forestry Research Institute. Tell us how nanotechnology and forestry work together.
Well, for some, it's a difficult marriage, thinking from the very small, the nano scale, up to the scale of the trees that grow in Alberta. We have to remember that Alberta is approximately 60% of our land base is covered by forests. And the Alberta economy has been impacted greatly by the forest industry over the entire history. But the forest industry is suffering these days. The economic downturn, the crash of the housing market in the U.S., international competition has made it extremely difficult for the forest industry to compete. So we're looking for new and innovative ways for the forest industry to develop new products and improve products for the marketplace, which will enable them to continue to prosper in Alberta.
Well, what sort of things? I mean, you know, when you think of forestry, you mentioned you do think of housing, you think of 2x4s, that sort of thing. When you think of nanotechnology, we're talking about a billionth of a meter. How do the two, I guess, what sort of products would you be coming up with from the forest?
Well, oddly enough, if you look at trees are made of cells, the same as every living organism, and those cells have walls. And it's those walls that form the products that we're typically aware of. The pulp and paper that we utilize in our society, the solid wood, the lumber, the decking that you have on your deck outside your home. But what you have to recognize is that those walls are made of very small components. In fact, nano components. And we find that one of those components is nanocrystalline cellulose. Nanocrystalline cellulose is somewhat akin to carbon nanotubes that you might recognize from the high-tech sports cars that attend the Formula One races. People have found that nanocrystalline cellulose is a good basis for new product development. And in fact, if we go back to the turn of the 20th century, aircraft were made from forest products, from lumber. In the future, aircraft bodies may very well be made of composite materials that include nanocrystalline cellulose from trees.
So in essence, from lumber again, but at a very different level.
At a very different level, yeah.
What sort of other things would you be making with the forest products? Because again, people today are thinking just wood. They're thinking chairs, tables, you know, things like that.
They are. The pharmaceutical industry is very interested in nanocrystalline cellulose, as is the cosmetics industry. It could be used for surface coatings to enhance the hardness of surfaces. It has color properties that can be triggered to give you a much better finish on some of the materials in your house. Some of the cabinets that you might install in your house can be treated with nanomaterial and provide a whole new product line for companies. You mentioned the conference. The conference provides an excellent opportunity for exchange between practicing foresters and the researchers engaged in nanotech research. Out of that dialogue, we hope will come the opportunity for new products to be developed, research to be conducted, and for forest industry in the province to capitalize on that and benefit.
Right. We've only got about 30 seconds. How far down the road is this technology going to be put into use?
How far down the road? Well, I think that we're already on the threshold of some new nano applications in the forest sector. Nanotechnology has focused on the electronic side of things, and you have to recall that the forest industry utilizes a lot of electronics in its processing lines. So we're there now.
Okay, thank you very much, Steve. Pleasure chatting with you. We're going to take a quick break. When we come back, we'll have a look at the long-range forecast with Carla and